Good afternoon, everybody, and welcome to this session. I sort of feel I want to move you more towards the center. This is a really interestingly shaped room, and maybe not so easy. Can everybody feel that they can see the speakers, they can see me? If you want to move in, please do. We'd welcome that. So just an announcement as we start. So please participate in the Q&A session by using the Pigeonhole Live and log into pigeonhole.at and key in the password that you see here, PIC24. You may send your questions or vote for existing questions, and this information will be found on the LED projection screens that you can see in front of you. So we'd love this to be participative, for you to ask questions when we have our 20-minute discussion section at the end. So this session is about training an early career scientist. So it's really lovely to welcome you, and I think people have said this several times during the meeting, is that, you know, we want to see the next generation step up. So this is your session and your opportunity to ask questions. So we have three amazing educators and people who are really committed to training and advancing the careers of young scientists. So our very first speaker is Dr. Sharon Plon, and she is from Baylor College of Medicine. She is a board-certified medical geneticist and a long-standing cancer genetics researcher with a focus on identifying new cancer susceptibility genes and studying the implementation of genomic testing in medicine. Dr. Plon holds the Dan L. Duncan Comprehensive Cancer Center Professorship at Baylor College of Medicine in the departments of pediatrics and molecular and human genetics, and is a member of the Human Genome Sequencing Center. I think she's got a vast experience behind her, has probably mentored and taught so many young clinical geneticists and scientists. So regarding training, she was in the leadership of the NIH-supported Physician Scientist Training Program for 25 years, and is currently the Assistant Dean for dual degree programs in the School of Medicine at Baylor College of Medicine. So she's going to talk to us today about nurturing the physician scientist needed to make precision medicine a reality. So welcome, Sharon. Thank you.
Okay, I am going to stand here because all of you over there, every time that door opens, it's really noisy. So if any of you want to get up and move over here, I recommend it. But, so many of you know me through my work in genetics, but I did spend 25 years running an MD PhD program, and I'm now a dean. So I'm going to talk about physician scientist training. I will start off talking about that training in the United States, but then we'll sort of expand to global programs and also just try to say what are the real challenges those programs face. So this is just an outline of what I'm going to talk about. Each of these topics are very brief, so don't worry too much about that. And I'll just talk about what kinds of programs currently exist, how they're structured, and then highlight some key programs in Asia, since we're here, funding, which, like everything, you have to follow the money, and then what are the challenges. So I think it's important. Many of you are physicians. I apologize, this is sort of focused, my particular talk, on physician scientist training, but we'll hear about other types of trainees as well today. And really, what I often think and what I often say is that we do serve as the bridge. And we often bridge scientific research and clinical patient care. I've worked with very large teams of bioinformaticians, oncologists, geneticists, and you're often one of the only people in the room that can speak both sides' language. And that turns out to be critical in getting large team science projects to be successful. So if we talk about precision medicine, and now I see why everyone stands here, because that camera blocks the screen, is just for the speakers. Yes. if you think about precision medicine, obviously, again, they play the bridge, but now you have to think about training in specific areas. And I think this is important for the trainees in the room when you want to think about what courses may be most important for precision medicine. So obviously, as you can tell from all the talks at this meeting, understanding population genetics. We haven't talked as much about epidemiology, but genetic epidemiology is critical. Knowing biostatistics, do not shy away from math, those of you who do. And then obviously genomics, and then study design. And I think that's something we don't do a good enough job training, which is depending on the type of study you want to do, you have to set it up differently. So if you think about how physician scientist programs are structured, and actually internationally they're not that different, the goal is to try to integrate medical education and research so that you're not doing the two things completely separately. That is actually more difficult in the United States now because the medical school accreditors do not want you to integrate them very much, but we still try. You need experienced faculty, so the mentors that are going to work with students, this will come up multiple times. And sometimes you have to bring in experienced faculty from other institutions if you don't have them. So for example, at our program, some students went to Rice who wanted to learn bioengineering because we didn't have engineering at our medical school. And then of course, you have to have access to labs and you have to have projects for students to do. So how are they structured? So I sort of cut and paste this together. In the United States and in some other countries, they're what we call a sandwich. Students in the United States do an undergraduate degree, they start medical school, they generally do 2 years of medical school, they then take a leave, and they go and do graduate school for 3 to 6 years, and more like 3 to 5, but and then they come back and finish medical school. So the goal is to complete it all in 8 years. Some programs are in 7 years. At Baylor, sometimes it takes 9 years. A lot of it just depends on your research and depends on what kind of clinician you want to be. If you want to be a neurosurgeon, you have to do a lot more clinical work than if you want to be a pathologist in medical school. I'm not criticizing pathologists. In many other countries, they complete medical school completely. So they may do their basic science and their medical school. And then instead of going directly to a residency, they may do their PhD at that point. So the structure tends to vary depending on where you're trained. Now, a couple of things I just want to say is I think there's a lot of misunderstanding. Most people think, and this was true when I trained, which I can just tell you was a long time ago, most people thought that MD PhDs or physician scientists only did basic laboratory research. There have been big studies in the United States. That's absolutely not true at all. And it's also true that you see every combination possible. So you see people doing 100% research and no clinical work. You see people doing 90% clinical and 10%. There are a lot of people in the sort of middle, 60 to 70% of one, 30 or 40% of the other. And I think that's just because clinical medicine has gotten a lot more complicated, funding has gotten more complicated, but you shouldn't think that, oh, if I do this, I'm only going to be a basic laboratory researcher. You'll see on the next couple slides that many MD PhDs do all kinds of research. This slide, what I really only want you to pay attention to is the sentence at the bottom, which is a big question is, well, do I need to do combined degree training at all? Can I just be a researcher with an MD, or at least in the United States? The data is the data. Only, and what does it say? 3% of MDs in the United States are MD PhDs, and we hold 50% of the grants that MDs hold. So we are much, much, much more likely to go on to be grant-funded researchers than people that do MDs only. So I think for the trainees in the room, and again, you're from different countries, so you have different options, it's important to realize that you do need several dedicated years of research training if you're going to be successful. Joanne has given a couple of talks since I've been here, and she talked about how she went to the US for 1 year, and Kara Zhang said, well, you're not ready. And in the end, she stayed for 4 years before she was ready to have her own lab. So it's just to say it is, in order to be a successful researcher, able to get grants and be a leader, it does take several years of training. That could be after medical school, that could be in the middle, but it doesn't happen magically. And these data sort of suggest that. Even though we're only 3% of the physicians in the country, we hold half of the grants. Okay, so what are outcomes? You can do any kind of residency training or clinical training in the United States. People are pathologists, people are neurosurgeons. It's definitely true that the surgeons, and I'm married to a surgeon, generally have much less time to do research than physicians in other fields, but there are many examples of successful surgeon scientists, pathologists, geneticists, so it's not just one field or another. The alumni surveys in the United States suggest that a majority, but you'll see again, it's not by far the large majority, spend at least half of their time doing research, the other half of time doing teaching and clinical work. Okay, so just what kinds of research? This again is just, so the pie chart on the left may not be so relevant to other countries because you all have different kinds of careers, but in the US, it's about 60% of MD, PhD graduates become full-time professors, we would say, medical school faculty. About 25% go into private practice, and then people do all kinds of other things. They go into biotech. Kyle, who talked at 1 o'clock today, is an MD PhD grad who started a lab at Illumina. So people do all kinds of different things. And again, just to emphasize that you can do all kinds of research. You can do basic research, you can do translational research, you can do clinical research. So just to finish up, give you some examples. I talked about the US. There are programs around the world. I think we may hear about the University of Cape Town today from one of our speakers. There are programs in Cambridge. They all have slightly different makeups, but they're all very similar in some ways. There's medical training and then about 3 to 4 years of research training in many different fields. In Asia, again, there are many such programs. There's a new program being started in Korea that has a focus on bioengineering. And again, many countries have recognized the need for physician scientists. So, since we're in Singapore, and this is all from the web, so don't shoot me if it's wrong. So the Duke National University of Singapore program has an MD PhD program. And again, they can do their PhD in a wide variety of fields. And again, the graduate degree takes about 4.5 years to complete. And this is the one from Korea. So I just want to finish up and talk about practical things. Where does the money come from? These programs are expensive. I used to always say to my dean, we were the most expensive training program in the medical school, and that was true. You really need either national or regional funding. Some programs do have support from private organizations. The program at Baylor actually had a lot of support by philanthropists, by people who gave money specifically for physician scientists because they saw them, training programs, they saw them as the future. Sometimes there are global institutions, Wellcome Trust, things like that. And then there are sometimes individual fellowships you can apply for as a trainee. So that's always something to pay a lot of attention to for the trainees. Are there national or international organizations that you can apply yourself to get funding? Like we had a medical student who submitted one last week who I helped her put the application together. So then what are the challenges? I would say the biggest challenges are trying to balance your time. There's more and more demand for clinical time. There's more and more demand on the research side. If you want to get a research grant, to have it be very high quality when you submit your application. So you're definitely balancing your time. If your curricula is flexible, that really helps. Like I said, in the United States, that's a big problem right now because the medical school accreditors have decided to not be flexible at all. But in other countries, the situation may be better. You definitely need dedicated research time. So I've said that a few times, but becoming a researcher takes years of effort. It's worth doing it. You ask most physician scientists, they'll tell you they absolutely love their career, but it does take time to do it. And you have to be persistent, which means you need encouragement. So I think my second to the last slide is about mentoring. So this was a nice study from Japan where they interviewed physician scientists. And it's actually a much longer study. I just took a few points. And they said what was important about their having a longitudinal mentor, someone who helped them along the way. So the first was just some sense of security. There was somebody you could turn to and get advice. Even when you were done your training, they still were there to mentor you. Obviously, they might serve as a role model, like you watch them struggle and then finally get the grant. That gives you some idea of what's involved. One of my former trainees called me and said, I'm really upset with my grant review. I bought her chocolate. I went downstairs. She gave me the grant review. And I was like, this isn't bad at all. You should give me the chocolate back. So trainees don't necessarily know what a bad review is versus a typical review. I thought this was an interesting one for the women in the audience because it's absolutely true internationally that women mentees found it very helpful to have a mentor help them through what is still a male-dominated academic structure. And then, this idea of having organizational continuity. I think what that means is when you go to apply for your first job, when you go to apply for your first grant, you have someone there to help you. So mentoring is definitely critical. So in the early faculty years, so now you've done all of this and you get a job, what's most important? So this is just an example of a paper a couple of years ago. Indiana decided that they really wanted to try to help their physician scientists succeed. And so they came up with this idea of super mentors. So these were people probably like me now who would then advise their physician scientist faculty, even if they weren't working in the same area. And they got typical one-on-one mentoring from their division head, but they also got this targeted feedback from another physician scientist. And they got grant writing support and biostatistics support. So again, statistics are critical. And in fact, they showed that those trainees were much more successful in writing their first paper from their own lab or getting their first grant. So where are we going? I think if you think about precision medicine and everything you heard in the meeting, there's an increasing evidence on interdisciplinary training, learning genetics and diabetes, or learning epidemiology and genomics. Obviously, as I mentioned, there are more and more programs being developed, and really, many of them are collaborative programs between two different institutions, one that might have the research training, one that might have the medical trainees. And of course, we encourage participation of trainees in these programs, because that's what we'll really need for precision medicine to be successful. Thanks. I think I'm on.
Thank you so much, Sharon. I just love what you said about precision medicine being about team science, and that very often it's the clinicians who are the bridge between what is necessary for a patient and then the scientist expertise. So I have a colleague who's a clinician scientist. She's a nephrologist, and work with her a lot. And she once said, the magic happens when you have the pure scientist working with the clinician scientist, and I think that's very true. Sharon, thank you so much for also emphasizing the role of mentorship, but also role models who can help you through this process. And I think you made it very clear that research funding is critical, so you have to learn the skills of how to get the funding for the research when you go down this route. So our second speaker today is Richard Haspel. So Dr. Haspel is Vice Chair for Education at Beth Israel Deaconess Hospital and Professor of Pathology at Harvard Medical School. He's the co-lead of the Global Genomic Medicine Collaborative, the GGMC Workforce and Training Committee, and he's received grant funding from the US National Cancer Institute to develop genomics curricula for medical students, residents, and fellows. So if I understand this well, you're actually going to be talking about how do you get the pure scientist to understand what it's like to work in a clinical environment, because, you know, as Sharon was saying, we need to be able to talk to one another. So thank you very much.
Thanks. So thank you for the introduction. I want to thank the organizers for inviting me here. And it's great we have an education session, because everything that's been talked about today, we need to educate people, to implement things, to figure out how to use the data, for all sorts of stuff. And the nice thing about education, it doesn't cost nearly as much as sequencing. So it's something that we can all work on. So what I'm going to talk about is a course we've developed to help basic researchers know, to bridge that gap between basic research and clinical, so basic researchers know a little bit more about what clinical people do. And, you know, everyone's going to say, well, that's, you know, of course we have to do that, but has anyone really, how do you do it, right? It's nice to say things. So I'm going to give some examples of what I'm talking about in terms of why basic scientists need some of that knowledge. And then I'm going to talk about a model we've used for physicians to teach them about genomics. And then I'm going to say some of the preliminary work we've done with this course for basic researchers. So I think everyone's going to agree basic clinical integration is important, but what does that mean? So here's an example. Studying genes relevant to human disease, right? So here, wow, that is small and harder to read than I expected. So, but anyway, I think I know my talk, okay? So basic reason, so there's a gene SERPIN-A, antitrypsin. There are a lot of splice variants, okay? This is from a paper about that, you know, open reading frames, pretty hardcore, you know, genetics. But this gene is very important in chronic obstructive pulmonary disease. So, you know, people need to know how that intersects, right? It's nice to know about splicing, but if you know about splicing and the disease that it might be related to, you might be able to guide your research better. There's also, of course, model organisms for human disease. This is a child who had intractable epilepsy, and they found a variant. So what they did is they actually used, what did they use? Xenopus to show, and it was obviously Xenopus, it's not even a mammal, but they were able to show that this drug called memantine was able to affect this channel. And guess what? They went back and they treated the kid, and the kid did better. So again, graduate students need to understand the opportunities for interaction between basic research and clinical disease. Here's another example I find, I mean, this is one of my favorite examples. So there was a report that this variant causes hereditary multiple sclerosis, and they had this nice pedigree that said, oh, of course, it causes this, you know, very clear-cut, you know, genetic disease. But then there was a letter to the editor, and they used a nomad, right? And they said, guess what? It doesn't work. This is too common, all right? So there was a lot of back and forth in the literature, like them going at it a little bit. But the point is, graduate students need training to learn about things like human variant frequency and how to use online genomic tools that are clinical. Because if you want to know if your gene has any importance clinically, there's ways to look it up. And this was just a paper in Cell, and it says a lot of things we believe. You know, close collaboration is important, promote cross-disciplinary understanding. But how do we do that, right? It's nice to talk about it, but how can we do this in a structured way? The other thing is, this is US-centric, but I think the need for people who know how to do clinical genetic testing is very important. So this was a workforce survey. The average age was 55. And again, these are PhDs. So this is another career pathway that people might not be thinking about. And if you look in the US, these people are older. A bunch of them are thinking about retiring. So this is a job opportunity because there is a bottleneck. You do your postdoc, but then getting jobs. So this is a career opportunity. So, and this was just a quote, that the genetics field needs to foster the next generation of laboratory geneticists who can be PhDs. But how do we get graduate students to learn about these opportunities? So we created this model about 10 or so years ago. It was for teaching pathology residents about genomics. And there were a couple components. One, we formed a national working group. And genetics and genomics is a team effort. So it wasn't just, we had representatives not just from pathology organizations, we had one from the American College of Medical Genetics, we had one from the National Society of Genetic Counselors, because we all have to work together. We developed a curriculum based on principles of adult learning. So just like you need to have expertise in being a geneticist, we are beginning to understand you need to have expertise in education. There are evidence-based ways to design curricula that work better to teach. So we created a workshop, and we've done a bunch of workshops internationally. We also created tools so people could implement these programs. We started with local residency programs. And we actually used a national resident in-service exam to look into implementation. And again, education research. I'm an MD PhD. I did molecular cell biology, but my research is education research, and you can do scholarship in medical education. So we've published, and again, it's funded by an NCI grant. So this is just showing a bunch of the workshops we've done at a lot of different society meetings, things like that. And we use this team-based learning because we want to learn how to use online tools. You can't lecture that. So there are some small lectures to just get everyone on the same page, but then the learners have their computers out, they're talking to each other, and they're using these online tools on real patient cases. So we provide comprehensive guide. So we wanted to get other residency programs to implement this. So we created like a 60-page instructor handbook. We created a toolkit that has PowerPoints, Google Forms, everything you need to implement. I'll show this later. All this stuff is available for free. But we did, our last survey was in 2020, and what did I put there? About almost 40% of residency programs in the US are using some component of this curriculum. So again, this is a sort of a proven model. We've published a bunch of papers about this. The first one was more subjective. Did they like the workshop? Did it meet the objectives? Did it help them? The second one, we actually designed a validated survey using the same tools you use for board or licensing exams to really show there was an increase in knowledge. We've also created some online tools that we've used testing for. And this was what I mentioned. We actually asked basically every pathology resident in the country how they're doing in genomics. And what we showed, not that this was all due to us, but what we showed, there's a gradual increase in their comfort with genomics. But when you ask them questions of genomics versus other things, they still weren't as good. So there was still work to do. And then what we did, so we're now in our third version of the TRIG, that's the pathology resident, and we're now in our second version of what's called UTRIG. This is for medical students. And we just had our second, we had a pilot with 49 students, a very good response rate, and a very high percentage would recommend or they thought it was worthwhile. And when we asked them, how did this affect your ability to, most of them said either somewhat or a great extent to use tools or to understand DNA testing. And I like to do this question where you ask for two adjectives that describe something, and this is a word cloud. So the larger things are, the more times the student put that in. So what we want to do is then translate this TRIG model to researchers. So we created something called a Nanocourse. So a Nanocourse is, where I am, is just a very short course. As you can see on the bottom, it was basically 6 hours, okay? And we did it twice. We couldn't do it during COVID. And I worked with a colleague, Dr. Cynthia Morton, who's a cytogeneticist, who's a clinical cytogeneticist, but also a researcher. And you get some credit for doing this. And I won't go through all the details, but the objectives were things like, why do you do genetic testing? How do you identify if a variant is clinically significant? We also did gene expression panels, so not just, pathogenic variants. So the exercise 1 was more germline, the exercise 2 was more somatic variants. And we also provided them information about careers as a laboratory geneticist. So the exercises. So first exercise, these are all the online genomics tools we use, okay? We use ClinGen as sort of a start, because I like to say it's like one-stop shopping. You put in your gene, you can get everywhere, but we use some other things like Medline Plus, Polyphen, some other things. And then the second one, we start by focusing on somatic testing and those databases, but then we show a cancer patient actually had a germline variant. So we recap some of the things with germline. So we use Google Forms. If people don't use Google Forms, it's great for teaching because, and you can see some of the questions we have. This is more of a thought question. We ask questions about ethics, right? We've had some great talks here about ethics. Something researchers need to know as well. I was once at a session where it was a question and answer with like postdocs and graduate students, and one of them asked, like, why don't we do more sequencing of infants? And it's like, well, there's some issues there, and we have to teach things like that. And then we had more of these, these questions, which were really, we gave them a genetic testing report, and we had them use the websites. The nice thing about Google Forms, you click on the link, it opens it up in a new page. And at the end, the learners, if they put their email, they'll get sent all their answers and all the references and everything. So Google Forms is terrific if you haven't used it. So I'll admit this, we don't have a ton of data. We've only done it twice. We only have about, what did I have there? 18, right? Mostly grad students, but we had some fellows as well. Wide variety of areas they were studying. And, a mix. 75% had used some next-gen sequencing, but less for some of these other aspects. Many of them took a grad-level genetics course, but not too many did variant significance. And actually, only 24% had heard of PhD clinical careers. So we asked them in our survey, have you used this website? Have you heard of this website? Or you've never heard of it? So look at the green. So the best we can do here is OMIM, I think, which is close to 40% have used it. But things like Nomad and other things, most of these people had not used these websites. And I'm not saying everyone is critical for what people are doing, but to at least know a little bit and what they're for, I think is important. We've gotten positive learner feedback. Almost all of them agreed or strongly agreed that it met the objectives, was engaging, they'd recommend it, help in their future career. 64% said it increased their interest in PhD clinical careers. And then we asked a similar question about, did they feel it changed their ability? So the purple is what we're looking for. And look at that increase in learning about ethics in genetics. 80% said it to a great extent, all right? And most of them, if you look at great extent or somewhat, are all well over 90%. So again, this is subjective, but at least it shows that there is some, people are feeling they're getting something out of this. So here are some of the comments. We asked them what are the best things. And, things like, I learned about these tools, applicability of these concepts to real-world problems, opportunity to collaborate with classmates, hands-on learning. One of them, one or two wrote about career options, and something about how samples are done, right? How do you do a study with human samples, right? And for a stronger workshop, so a lot of these were actually logistical. It was things like we wanted more breaks. But, and it was also interesting, one person said more somatic cases, the other one said more exposures beyond cancer, so, and I think this last comment, I'll let you guys read it, because this, well, I'll read it. Like, bring together doctors, scientists, ethicists, et cetera, to stimulate the real interaction between the engaged parties and to reveal if and why we have sometimes gaps in communication and how we can improve collaboration. Bring also a voluntary patient if it's possible. So that was what to improve, but it shows we got the message across that we need to work on this stuff. So bridging the basic research clinical gap. So this is still in its preliminary phases, but I'd love to share it if people are interested in implementing. I would probably ask, though, that if you do that, you give a feedback survey so we can collect more data on this. A lot of our other materials are available online, and we have a bunch of different systems for that. I mean, a bunch. We have the pathology residents. We have the medical students. We just started last year. We're working with the American Society of Clinical Oncology in the US, and we're doing pilot programs with oncology fellows throughout the country. And the other thing is we have these non-oncology universal exercises, which we created through a group at the NHGRI, and we got some supplemental funding. And the idea was, a lot of the things you have to teach about germline are similar in the sense you use similar tools, ClinVar, OMIM. So we basically created these plug-and-play modules where you could just add your disease and variant. And we use these, we have examples in neurology, ophthalmology, cardiology, and pediatrics. And we did it at some national meetings like the American Heart Association, the American Academy of Neurology. So this is also a tool we've used not just for somatic, but also for germline testing. And all of these things, we have all the things you need online, all the tools, the PowerPoints, everything that, and this handbook to help implement it. And that's what I said in the last line there. So I'm not going to obviously name everybody, but these are all based on committees. And the committees are experts in different areas. So TRIG is our, pathology residents. UTRIG is our medical student. ASCP, the American Society for Clinical Pathology, has provided a lot of our educational design support. As I mentioned, creating curricula is pretty darn important. And you can't just, it's no longer just a couple people sitting in a room and putting something together. You really need to think about what works. And then for the Nanocourse, I of course want to thank Dr. Morton, but also it's really nice at Harvard Medical School in the genetics department, they actually have curriculum fellows who spend, I think, 2 years just focusing on education. And the curriculum fellows were huge in helping organize this Nanocourse and helping us, with logistics. And of course, they all have PhDs in genetics, so they can also help us from that perspective, because they're closer than I am to being in grad school. So just, we have a website. If you just type in TRIG in genomics, it'll come up. And you can basically, everything's free. We just ask you register because we have a grant, so we like to keep track of who's using it. And we occasionally send surveys out to get an idea of use. And so it's free access. Actually, we're hoping this year to have the most recent versions of the medical student, the pathology resident, TRIG and UTRIG, out by the end of the year. The non-oncology universal exercise are there, everything. We also put workshops we're having. We're having a couple coming up at pathology meetings. And the Nanocourse, like I said, we've only done it with whatever it is, 18 people. So it's not on the website yet. But if anyone's interested in doing this, or if you're a young investigator and you want to do there's real opportunities here to study this curriculum and figure out ways we can implement it and look at outcomes and things like that. So anyway, thanks again for inviting me. And yeah, we'll take questions later. So thanks a lot.
Rick, thank you very much. And I think many of you may not have thought about having a career in education in precision medicine, because I think that's like a way of also amplifying the message. And Rick, it's really wonderful that all these materials are available to anybody anywhere in the world. So I think they can really make a difference. And using real-world examples are fantastic, because that's what people are dealing with. And I think students and young investigators, if they know this is something that is real, it's sort of a better learning opportunity, but also that emphasis on the ethical issues and not can I do it, but also should I do it, and what are the implications of doing that. So the last speaker in our session today is Dr. Vicky Nembaware. She is a Zimbabwean who has been working in South Africa for a very long time. You may have realized from my accent I'm also South African. I don't think I introduced myself at the beginning. But Vicky and I have known one another for decades. And what I do know is that she is really passionate about educating the next generation and making sure that as many young investigators in Africa as possible are aware about genomics and can train in that field. So Vicky, over to you.
Thank you, Michele. And thank you to the organizers for having me and for all of you for coming to this session. Great. Okay, great. So the title of my talk is really about inclusion and equity and capacity building for early career genomics researchers in Africa. And those are my affiliations. And just to acknowledge the work that I'm going to present here is work done by many people across the continent, different partners from all sorts. I'm sure these are only a quarter of them. There are more who are involved. And also some key people. I think you will see Michele in this photo, somewhere in the white jacket, during a meeting where we actually had a working group, focus group discussion to discuss curriculum development in Senegal, Dakar. And I think just to take off from the last speaker was saying curriculum development is not trivial. It's really a lot of effort and a lot of work and collaboration as well. And I just highlighted some people as well on the slide. Nikki Mulder, who's really supported a lot of this work through funding, and some coordinators who've helped coordinate some of these training activities. And the guy in the shades is actually a collaborator from the Department of Education, and you hear more about that. And that is a developer who has developed some tools which we've been using in some of the training. So just to highlight that African genomics is becoming very relevant, to the human health and understanding human evolution, and it's really a hot area at the moment. And I think what's key is to make sure that we have a big, diverse workforce to work on this. Diversity is really critical. It increases innovation, productivity, cultural competency, problem solving, equity, lots of things. And I feel that as upcoming fellows in genomics, it's really important to always reflect that when you go into a group, it is diverse so that you're also enriched and you grow in that area. So for this talk, I would talk about some training activities, and hopefully this will also make you reflect and also realize some opportunities that are available. The first one is a small project that we did to really strengthen the skill sets of the current workforce. And here we're focusing on global researchers so that they're able to mine African genomics. And really this is to create an equitable access to the data, because we understand the value of the genomics, the African genomics, and it's really important for us to open it up to the global populations in a manner that is equitable. And then I'll also talk about how we try to turn around the fact that a lot of healthcare workers, including physicians, are traditionally data collectors in Africa, but yet they can contribute very effectively and improve the research that is going on the continent. And it's also a challenge to throw back to you that, if you're an MD, to also really consider the fact that you could turn into a physician scientist instead of being data collectors and really contribute. And then I'll also focus on another project that we've been working on with the Department of Education, which I highlighted earlier, about how to look into the future to make sure that there is diversity in the future workforce. And one of our strategies is to work with high school learners. And this is also a challenge to most of the young upcoming researchers in the room, that sometimes it's not always about focusing on your career. It's also about looking back to see how you can give back to the community and really expose young people to careers in genomics. So for the global researchers training in African genomics, we were approached by a center in Ireland, which was really focusing on training a cohort of PhD students in data science. And they wanted their students to really learn about African genomics. And this gave us an opportunity to actually assess the challenges that we're currently experiencing in Africa, that the research on African genomics is limited and the skill sets are limited. Although they are growing, there is still a need to really strengthen this. And also, we were also conscious of the fact that access to samples is very difficult. It requires a lot of investment. Why not actually train people to use existing samples so that research can increase rapidly? We also mapped out the assumptions. This is just to highlight that when one is training, you don't just jump in. You need to actually sit and strategize, map out your challenges, your assumptions, and then also look at the most effective implementation plan. The most effective, in some cases, might be online. In some cases, it might be, small group discussions. So we tailored this training to the needs of the of the graduate program that had approached us, and we also looked at the potential benefits, possible impact of this training. This is quite small, but this is just to highlight this is just to highlight what the curriculum involved or what we ended up with for this training. We had webinars where anyone could join. We had a background lecture which focused on really making sure that everyone got a very good foundation of some of the genomic concept, with case studies just to show what was possible with some of the African genomes that we had. And a key thing that I want to highlight is that we had practical sessions. So we sent 2 data scientists from Africa to the school to actually teach them hands-on, download data from a cluster and actually process the samples. So it was a full week, and at the end of it, just to really crystallize what we're aiming for was to give, to actually ask the students to develop a research idea or concept that included African genomics in it. So if you go to the URL code, you can actually access it, and if you've got a graduate program or you're graduates who would like to also be trained in access, in processing African data, you can sign up for that, and the society will review your application. We trained over 30 PhD candidates through this, and the webinars were well attended by different people, and you can see that. And we also published an article if you want to read more about the strategy and the implementation plan that we did. And the second case study that we looked at that we did was the African Genomic Medicine Training Initiative, which, as I highlighted before, was, amongst other things, aimed to flip the status quo of having healthcare workers be data collectors. And we really based this on a competence-based approach and a framework-informed approach, where we looked at the Ken 6-step approach and really followed it diligently to develop this curriculum. And the model that we used based on the accessibility of resources was that trainers had to pre-record, and classrooms within Africa would then access this material from their places with a facilitator in each room. So one key aspect I just wanted to highlight was that we wanted healthcare workers to be able to conduct some genomics research in some capacity, in their capacity that is ethical and appropriate to the context. And sometimes it doesn't mean that there would be PI, but at least they would be able to sit at a table and contribute efficiently. And the program is now expanded, thanks to Petunia, who's now coordinating. We have foundation courses where all the 3 groups that are being taught now, nurses, medical doctors, and pathologists, attend these core courses, which have got very basic information on patterns of genetic transmission, basics in genomics. And then after that, we've got streamlined modules which are specific for each healthcare group. Just to mention that the first group that we taught were nurses because we thought those would make the most impact in the clinics and in contributing to research. So in correcting these past imbalances in contribution to research, we really emphasized the research, aspect of it, making sure that they leave the course with some research training. The course has since expanded from training 225 people in one, training, which takes about 3 months. We now train over 840 in a year. And then the last project, which I'm hoping that you could take up as a challenge to see how you can also engage the upcoming high school learners or other, people who are not yet, who haven't yet made up their minds about where they want to take their careers, is the MGen Africa project. So when we started, we knew we just wanted to develop an app and to engage high school learners and to promote genomic researchers to engage with these high school learners. What activities we're going to do or what the content was going to be, we left that a bit open. So we made it a very collaborative co-design process where we co-designed the entire project with high school learners and also with the teachers, with the Ministry of Education, and with other stakeholders who are versed with community engagement skills. And at the end of it, we agreed with the stakeholders that we're going to deliver relevant genomics content in a relatable and fun format. And the fun was very important for the high school learners. And we're targeting all these skill sets there. And one of them, as you can see, was the ability to develop a career plan in genomics research. And for some of these high school learners from really disadvantaged areas, they had no idea that it was possible to have a career in genomics. So these are some of the activities that the high school learners can do on the app and on the Mobi site. There's a career spotlight where we highlight different career options by actually putting people's profiles, a live chat which has to be booked via the school, a quiz which is fun, which is aligned to the curriculum. The teachers were persistent and really insisted that the content needed to align to the curriculum so that at least we help them with the learners getting higher marks, training opportunities, and bursary opportunities, a knowledge corner where we have like fun activities, videos, comic books, explaining principles in genetics, and the translation corner. As you know, Africa has got thousands of languages, so we made this as a way to actually capture how people understand genetic terms in their own language or in simplified English. And we also have a corner where we ask the learners to think about hard ethical issues in advance, which they might have to make later on, since they will be genetics consumers. This is just a picture of all the activities which we do face-to-face in addition to the online platform. And one extra activity that we've added, which is supported by the PubGem grant, are debate competitions, which have been fantastic and well received. There are lots of evaluations going on, both formative and summative. The formative ones is really to inform the implementation and development so that we continually learn from the learners and from stakeholders, process evaluations, and we do pre and post knowledge, attitudes, practices, and intention surveys. And we also have some case studies ongoing to try and track some of the learners who have attended our activities. For them, it was the first time interacting in genomics. So we're really trying to strive towards addressing the past so that we act wisely in the present and to prepare for the future towards creating a diverse workforce in genomics. Thank you.
Thank you so much to our three amazing speakers, all coming from very different backgrounds making a difference. Vicky, I think your energy in keeping all these activities going is just phenomenal. And I think, to all of you here, thinking about that example of how we get people at school to start being excited about precision medicine, about genetics and genomics, because they are our future, as you said, Vicky. Great, so we have some questions already from you, so I hope that you will all sort of go into Pigeonhole and also add, because we'd like to hear from you what you would like to know. So I'm just going to activate the first question, and that is about how to develop and test one's research idea for relevance and robustness. So I guess that is also part of learning and trying to decide, what you're going to do when. And I guess it does depend on different sort of backgrounds as well, what people want to achieve. Would anybody like to have a go at that? If you have an idea, how do you decide it's worth pursuing in terms of research?
So I was it's actually a great question, and I think part of it is, number one, don't be shy. There's some famous scientists who have said, you should work on something important because research is really hard, and so when things aren't working, you want to really care about it. But I think in the context of precision medicine, it is really important to think about some of the talks and size, right? So in terms of precision medicine, you really do need to think about how large a population do I need? Is that something I'm going to do, or am I going to tap into one of the great resources that we heard about and collaborate with someone who might already have a cohort? Creating your own cohort is a huge endeavor. So as a trainee, think about a project where you can perhaps use an existing one, where you may, in the long term, help to develop a new one. But that was also my comment about biostatistics, which is sometimes people really start whole projects and never really think about, well, what's like the statistical tests I'm going to do to show that it worked, right? You heard about that a little bit in evaluating education programs. So don't shy away from learning statistics or reaching out to a statistician. What they hate is when you've done the whole project, you come with the data and you walk up to them and say, here, can you calculate my p-value? Most of the time they'll tell you you set the whole thing up wrong to begin with. So again, if the question asks about robustness, think about that up front. What statistical test is going to make sense?
We go in order? Yeah. I'll just say, one of the points you brought up about mentorship is that's why you have a mentor, to help you figure out how to explore you need to be able to, and I'm great, you brought up Kern. So Kern is curriculum design, but a needs assessment is fundamental, and you have to know how to search the literature, and you have to have an advisor or a mentor who can help you with that. So I think it's a complex thing, but it really emphasizes you need to be taught, and you need to have someone to help you with that.
Great. Yeah, so I think it's a great question. I think personally, before I embark on any research project or any implementation project, I look at the end result. What is the impact that this is going to make in people's lives? What is the impact or the outcomes that I'm going to reap out of it? If you cannot publish a paper out of it, then as a researcher, that's not really fruitful, right? And if it's not a study you can say in one sentence to convince a funder to give you money, I mean, we kind of work all the time just to get more money and more papers and make a change in people's lives. So I think those three rules, those are the ones that I use most of the time. Is it really making a change in people's lives? Can I publish out of this? Can I get more money? Can I convince someone to fund me?
I think those are all great answers and good advice. And Sharon, also what you were saying at the beginning is you don't need to have a big grant or a lot of money to do that first research project. But it is about knowing how to ask the right question. Because I think very often that's where you struggle, is if you can't ask that question. And I think your 3 rules in terms of, is this going to be publishable? There is so much public data available now. Money should not be keeping us behind. It's more about ideas and questions. So I want to take us now to the next question. So we've spoken a lot about pathologists, clinicians, research scientists, but we haven't really focused on genetic counselors. And I wanted, the question here is, it's a term now that is also including clinical application, because genetic counselors actually work with patients. So the question is, what career advice for genetic counselors would you give if they want to pursue a research graduate degree? So if you train as a genetic counselor, how do you get into research? Anybody want to tackle that one?
Well, I will say that NHGRI in the United States, for the first time has made it more straightforward for genetic counselors to apply for training program grants. I do think it's a really important question, and our program, for example, has now added, the program at Baylor College of Medicine, for example, because of this issue, joined a national network that allows genetic counselors to do an extra year of research training. There are some genetic counselors who actually go on and get PhDs, but that's, of course, a long haul. But I do think it is difficult in a 2-year program to get enough training. They often play critical roles as members of research teams, and I've talked a lot with the genetic counselors work with us, and they often seek out workshops and other ways to get training. But I think some concentrated research training time is really important.
Great. Do you want to comment? You don't have to do every question.
Well, no, I'll just say I think a lot of genetic counseling programs you still have to do a thesis and you have to do research, and it's a question of there isn't as clear-cut, I don't think, a pathway, but you can get at least a taste of research and then think about and there are role models who can help with that as well. And I'll just say there's a group called ISCC PEG. It's in the U.S., so it's U.S. focused, but they have a scholars program that helps trainees, like genetic counseling students or people, to help explore with a mentor a research project. So there are opportunities. You have to find someone to work with and things like that.
That sounds really good. So Vicky, there's one for you here. Are there any plans to extend the MGen Africa project beyond South Africa, and what would it take to do that?
Money?
Yeah, so that's a very interesting question. So I just met with a stakeholder in the US, and they were saying, why don't you push this to go global? And we discussed that briefly in terms of what it would take. I think it would take some champions from different places. That's the first thing. Because when we started this project, we were not funded. The developer actually funded it for free for a year because he bought into the idea of exposing people to genomics and genetics. He comes from Congo and is now living in Canada. And he was like, when I grew up, I didn't even know I could be an informatics person doing genomics. So he was really passionate about it. So I think it would need a lot of champions across the globe to really, take it and run with it. And one of the key things I think for us that has worked for MGen is that you have to develop it with the local stakeholders so that it's accepted. So it can't just be rolled out as it is. It would need to be adapted to suit the environment that you're working with. Money wouldn't hurt either.
Never does. Well, yeah, never. Not too much.
Not too much, yeah. Yeah, more funding wouldn't hurt because people's salaries need to be paid. But otherwise, I think it's really the passion and the drive to get it up and going that would really make it go global, especially the quiz competitions. We've been approached by a few stakeholders who run Olympiads who were saying maybe this could be a global Olympiad, where people compete in the quiz competitions or whatever else. Yeah. So thank you for that.
Yeah, because I think, the point that you make is context does matter, and also how you worked with the teachers to make sure that the content was aligned with the curriculum in South Africa. If other countries were going to use it, they may need to go through a similar process. But, you've got the example and you've shown the impact. So that would be very interesting. There is a question here that's been upvoted, and I'm not quite sure what to make of it.
I
You
think
can actually read that? Good for you.
I can read that.
Wow.
And I think that was for me. It came up when I was talking, and I first thought it was going to be one person, and I was going to suggest discussing it over a glass of wine. But the question is about exit strategy. And I'm sorry. Can you please share about decision-making process on exit strategy? How do you determine when to call it a day and move on? So, no, this comes up a lot in physician scientist training. I've had hundreds of MD, PhD students go through my program, lots of discussions on exit strategy. So I think you do have to love the research. You do also have to realize that there are definitely going to be down days and real obstacles, grants that don't get funded. I think it really, to me, it comes down to, are you really not having any fun anymore? And can you really see yourself being satisfied in another career? I think people, though, get very short-sighted in terms of time. So if you ask most physician scientists, while they're in the program, the 3 or 4 extra years seems infinite, right? In fact, one year our graduates all put the infinity sign on their graduation caps for just the MD, PhD grads at medical school graduation. But if you ask people 20 years later, it seems like that was such a short investment for the impact it had on their career. And so I think you do have to sometimes not just talk to each other. That's about, where you're all commiserating how miserable you are, but actually talk to people a little bit down the road as to whether that struggle is worth it. But obviously, people make decisions. As I mentioned, 25% of graduates in the United States are in private practice. We have people, actually one of our graduates works for Apple Health. I mean, one of the things to think about is that there are all kinds, and this is true globally, there are all kinds of careers now where you can apply your strengths. So I would just say, in terms of exit strategy, make sure you're sort of taking a long-term view. But, sometimes that's a decision you make.
Right. I'll just, because I did one of those MD PhDs, and I definitely changed strategy. I think it is difficult. You start when you're, not to offend anyone, but 22, you think you're going to cure cancer and everything. And by the time you finish, all your friends have finished their residency, and you're just starting a residency. You're trying to have a family. It can be a very challenging time. So I think, like Sharon was saying, you have to think critically, but there's also nothing wrong with changing directions. And what happens is, like, for example, my career now, I'm a clinical pathologist. I work in a lab. I didn't even know that existed when I was in medical school. I did a year of medicine, and I found out there were things I liked, there were things I didn't, and I changed. I became a pathologist. And yeah, now I probably couldn't switch careers, but a lot of people think the decision they're going to make when they're in their 20s is the last decision they have to make. But you can change careers, and it's okay. But make sure you're doing it with the advice of people and things like that, because it is a long haul, an MD, PhD. So, and there are people who, it's okay, but don't rush into it.
Yeah, I think I've had the opportunity to exit, the research arena for some time. So one of the steps was actually to take a break, because sometimes you don't need to exit. Sometimes all you need is just a month or two break, and also to, even if you do exit, I mean, I came back, and just to be open to the idea that it could be a phase, but also it could be you changing careers, which is, all the speakers are mentioning, it's not the end of the world, right? People change, and the great thing is that when you move to another place, you bring with you a very different perspective. So I feel when I came back to research after leaving for about 4 years, I also came back with a different mindset, which I think has made me enjoy research and genomics even more than if I didn't have that experience of exiting for a while.
And I do just want to repeat something that I think all three of us have now mentioned, and this is true of MDs, of nurses, of genetic counselors. There are so many different options that you are not actually aware exist. I didn't know medical genetics existed as a field when I picked my residency. So I started in oncology and then left and wound up going into medical genetics. It's just to realize that it's really important to talk to people. We had an MD PhD student who couldn't decide between neurosurgery or a postdoc. And I said, well, those are two really different things.
I'll say, Jesus.
I said, what about rehab medicine? Because he wanted to do robotics, like people who needed prosthetics. I said, well, what about rehab medicine? He said, what's that? He's now a professor of rehab medicine. So really keep your eyes open. There's so many different things that people can do with their training, and they typically only think, I think every one of us have said that. So really, go on websites, ask people. There are a ton of careers out there that, don't just talk to the people in your environment because they may not be aware.
And it's a thing we have to do better is make sure people know. But I'll also say, doing a PhD or spending extended time of doing research, it teaches you a way to think. So, and that's the thing, when you think about the model in the US, you're doing 2 years of preclinical and then you do your PhD. You're not going back to research if you do a residency for years, and you can debate that model, but the idea is it teaches you a way to approach things. So the things I learned during my PhD apply to how I'm a physician, they apply to how I do my current research. So I don't see that as, oh, I didn't cure cancer, but it was still very helpful and you can leverage those things if you do that training to a lot of different things. Yep.
Thank you so much. I think really good advice there. And somebody's asked about, how can you get into an MD, PhD program?
Yeah, so that I'm happy to, because that really depends on the country and everything. So happy to just talk one-on-one about that.
Yeah, and I think it will be country specific. And I think you've actually outlined that there's so many entry points. So maybe to go to the next one, which is, I'm not quite sure, whether they're asking, let's see if we can get this one up. It says, what would be your advice about bridging clinical scientist and a graduate with a degree in precision medicine, but not a clinician? So I don't know if the question is really about, where do you start? Do you become a clinician scientist, or do you become a scientist in a clinical discipline, but not a clinician?
Right. That is, it's, I'm trying to think. I mean, well, I'll just tell you, I thought when I was in college I was going to do a PhD. And then I actually started doing research in a lab that was run by a physician, and I learned more about what it meant to be a doctor. So I think the best thing you can do is try to learn the most you can about those things. We have an internship program for summer students from underrepresented groups. They spend a summer with us, so they learn about what it means to be a doctor. I think if you spend time in a lab, I think you have to get a taste of what that's like, Because being a doctor and being a laboratory geneticist or a genetic counselor, they're very different. And if you can have an opportunity, I won't take the whole 5 minutes, don't worry. No, I'm just kidding. No, I'm just joking. But the idea is, if you can try to get experiences with those different groups, try to see if you can shadow a physician or something, because some people think that's absolutely what they want to do, and they realize, I don't like this, that, or the other thing, or vice versa. So that would be the one thing I would say.
Yeah, it's a very personal choice. And I think,
Right.
you all emphasized, that precision medicine is a team sport.
Right.
And so you need people with different experiences, people with different training and different skills. So I think it is really about choosing the skill that suits you best and that you enjoy the most.
Right,
become a
exactly. And there are
valuable person of
people
the team.
who, they thought since they were 5 they want to be a doctor, but then when they just don't like certain aspects
They
of
can't
it, or
stand the view of
gross
blood.
anatomy or whatever, not to, that's sort of a cliche, but the idea is if you can get some sort of experience, because it's different than what you see on TV. I'll just say, most people think all pathologists do are autopsies, but actually we don't. So that's a good example of you need to experience things.
Absolutely. So, Rick, people seem to be absolutely fascinated by the Nanocourse.
Oh, well, that's cool.
And they want to know different things. They want to know how much time does it take to do it. I don't know if that was the 6 hour or whether
So
there's
if
something
that's
more
what
to
I meant,
it.
so preparing it took a while, but the actual course was 3 hours on 2 different days in the same week.
And did
Yep.
everybody complete it, or did some of them drop out?
You
after
know,
the first session?
I'm pretty sure that's always a good sign, right? Well, it's always a bad sign when they leave right in the middle of it, but when you have a break and they don't come back. But I'm pretty sure most people came back the second day. I mean, we don't have a huge N, but yes, people seem to be engaged. The one person, I said there was like 17 out of 18. Like the one person, that individual I think came back. I mean, because everyone came back, but their thing was it was too basic for me. Even though we tried to explain it, we had that we tried to explain this introductory, but that was like someone who's a genomics informatician, and I'm like, well, sorry. But no, I think, people came back, fortunately. Yeah.
I think you're going to have lots of people hitting your website
Okay.
soon.
Well,
So when it
it's
comes
great.
online,
yeah,
I think that'll be very
I'll just say one
interesting.
last
Yeah.
thing. To me, genomics education is like spreading the gospel. We need to teach people this stuff. There is data that people in I'll just say medical school, because that's what I'm familiar with, they know nothing. Genetics is in the preclinical year. There is no required genetics rotation. Many places don't even have a required pathology rotation. So the idea is, how are we going to implement this stuff if healthcare professionals don't know about this? So it is really important. So anyone, and the idea with basic researchers to also know, people talk about collaborating, but if you've never, you need to think of structured ways to educate people. And I think that would be great if people want to contact me. So.
And Rick, I think my message is always every discipline of medicine needs to know about genetics.
Oh my!
Because genetics
exactly.
impacts everything. Even our infectious disease colleagues, we have to say the host matters. So whether you get the disease running on depends on your host genomics.
Well, and the other thing is, no matter your specialty, there are going to be people coming to you with their direct-to-consumer testing, or you need to have, and our goal is, like for the physicians, or physicians, is be able to say, you're a cardiologist, that you can have an intelligent discussion with a geneticist. We're not going to make them into one, or you can call the laboratory and ask the right questions. And for the researchers is that you can have an intelligent conversation. You're not going to train people in a few hours, but it's about literally building those bridges so people can communicate better.
We're almost out of time, but maybe we can just have another few minutes. Please take the mic.
So, well, since we're in Singapore, we do have in the medical school, especially, we're just about to start a curriculum where genomics is going to be put in. Duke NUS has a graduate certificate where genomics is in there. So people who want to go, there are options for this locally here. But I wanted to ask the question was the complexity. So one of the problems I have whenever I teach at different levels is how much do you give them and at what point and at what time, right? Because sometimes, like you said, it's too, no, someone did say we always teach to the median of the average. It's never quite right. So that's a hard balance to get. I just wanted to hear from you guys, because, someone's going to be left hungry who wants more, and someone's going to...
Yeah. So, I mean, it's a great question, very important. So, for example, our medical student curriculum is different from the one that we give pathology residents, was different from the one that we give oncology fellows. So that's one of the reasons it needs to be a team approach in terms of getting people from different areas to weigh in. What we do, our model is, for the medical students actually, because team-based learning, we actually give them a toolkit beforehand, and we say, with definitions, with videos on how to make a pedigree, because no one wants to sit in lectures anymore, right? So you have to do it incremental, but I think you give them the initial toolkit, like what's a pedigree? How do you do sequencing? Things like that. And obviously you need a little bit, and then, then you move them a little bit forward to look at a variant. But you don't start with the VUS, It's kind of a team approach. It's hard to give a general answer, but it's trying to figure out where they are, and then you test it, and you see what did they get, is it too advanced, is it not? It's a tough question, but it's a lot, some of it's trial and error, and to figure it out.
Yeah, just to add to that, in South Africa, we actually wrote a textbook, Molecular Genetics for Clinicians, because we felt that the examples in the rest of the world were not appropriate to Africa. And, Singapore may have similar, specific examples, and that's always a way to pull in your clinicians is by appropriate things that they're going to be seeing a lot. There is one question. We've really focused... Oh, sorry. Vicky, did you want to say something?
No, it's just I feel for most curriculum development, thorough needs assessments need to be done. Right. So I think as we are trying to develop curricula to teach, there needs to be a research component, a research on the education, section. So a needs assessment helps, and also getting baseline data just to check where is everyone at, and I think aligning your content to the outcomes. It takes a lot of time, but just outlining your outcomes and your competencies so that at least when you test the people afterwards, you've got like clear outcomes and competencies that you're trying to target.
I just add really quickly, involve the people in designing your curriculum who are at that previous step, because they will be able to tell you what they think they should know. So.
I love this evidence-based teaching.
Needs assessments.
Yeah, that's wonderful. I think this brings us to the end of the session. I just wanted to take one question, and somebody, we've so emphasized being a clinician, learning about precision medicine and genetics, but somebody has asked, what about the other way around? Like if you start your career as a research scientist, can you go into clinical practice or become a doctor? And I know that I've certainly had students who've done that. So, if that is what you feel is your calling and what you want to do, don't be scared of then going into doing a medical degree. And you'll be very valuable.
A lot of people do a PhD and then they go to medical school.
Yeah.
It's fairly, or there are people in various careers in healthcare or research who then switch things. So absolutely.
Yeah, so definitely a two-way street. I think this, do you want to make one last comment? Because then
No,
I'm going to close up.
No, I was just going to say, what I always say to people, in the United States, it's very difficult to get into medical school. And I always say to people, if you look at a hospital, the number of people in the hospital that are physicians is maybe 1% of the people there that are taking care of patients. So there are many ways to take care of patients other than being a physician. So, they're nurse practitioners, they're radiation technologists, they're genetic counselors. There are many, many ways that we care for individuals. So just remember that, because depending on your country and where you are and what you can afford, being a physician may not be possible, but there are many, many other ways to be involved in the clinical enterprise.
Thank you so much. And I'm going to bring the session to a close and just thank our three magnificent speakers. You've all given us so much food for thought. And I hope that you all feel that you've learned something, that you have some ideas of how you want to go forward. So let's give them a big hand of thank you.